Okay, so let's read the question. Consider the function f of x is equal to -5 sine of x plus pi by 3 for 0 less than or equal to x less than or equal to 2 pi. The question asks you to solve for the value of x at which the turning points occur. So we know we need a value for x, and we know that this value of x is the x coordinate of a point, and we know that point is the turning point. Let's quickly review what a turning point is. I think you kind of already know what it is, but let's go through it quickly. So firstly, remember that a turning point is just still a point on a curve. It has an x coordinate and a y coordinate, okay? So here we have a curve, and here's an example of a turning point. And notice that it is the point where the curve goes from increasing values to decreasing values. And that's why we call it the turning point. That's what makes it special. Now, let's see a trick that we can use to actually find the coordinates of the turning point. Because remember, this is what the question wants. It wants us to find the value of x at which the turning points occur. So notice that if we draw a line running through the turning point, it's perfectly flat. This means that the line has a gradient of 0. It's totally flat, so the gradient is 0. But this also means, like we learned on Thursday, that the derivative of the curve, which gives us the gradient of a curve, that also has to be equal to 0. And this is the trick that we're going to use to find what the x value of the turning point is. So, in summary, we're finding the turning point. To find the turning point, we can find the derivative of the curve and set it equal to 0. So now let's go back to the equation of our curve. So we have this equation here, and we're going to find the derivative of this equation. Now, since we're trying to find the derivative of this equation, the first thing we can do is we can take this constant, we can take that outside of some brackets, and then we can derive what's inside these brackets. And we can do so using the chain rule. We have to derive the sine function, which becomes a cosine, and then because of the chain rule, we have to multiply by the derivative of whatever is on the inside of these brackets here. So the derivative of x will be 1, and the derivative of pi by 3, which is just a constant, will be 0, and that's what we get here. So it's basically just cosine so and so and so times 1, and obviously that's just cosine x plus pi by 3. And just to make things a bit neater, we're going to get rid of those brackets. We don't really need them anymore. So we end up with this. This is the derivative of our equation. And using the trick that we learned before, we set this derivative equal to 0. Now we can simplify this a bit further. We can divide both sides by -5. The side on the left is just 0 divided by -5, which just becomes 0. The side on the right, the two -5s will, the -5 on the top and the -5 on the bottom will cancel, and we end up with this. And we're just going to rearrange this a little bit so that it makes a bit more sense. What we end up having is a cosine of x plus pi by 3 is equal to 0. But we're not done yet. We still need to find the value of x, because that's what the question wants us to do. But there's a bit of a complication when it comes to trig functions, which is, simply put, there can be several values for x that work. And the way that we find the different values for x that works is by using the unit circle. For this video, we won't go into detail about how the unit circle works. We'll just use it to find the different possible values of x. Now, recall the point of this question. We just want to find the different possible values, or different possible angles, I should say, where the cosine of that angle is equal to 0. Okay, so let's draw our unit circle. And here's how we draw an angle on the unit circle. We draw a line like so, and then we draw the angle to that line. But because this is a unit circle, if we choose this angle over here, which is pi by 2, then the cosine of this angle is equal to 0. Not the angle itself, but the cosine of the angle is equal to 0. And if the angle goes down over here, then the cosine of this angle is also 0. And this angle is actually 3 pi by 2. This is simply a property of the unit circle. We can talk about it in more detail, but for the purposes of this question, all we want to do, and what we've done, is found two places or two angles where the cosine of those angles is equal to 0. Now, coming back to our question, remember what we wanted was the cosine of this angle to be equal to 0. And now we know that the cosine of this angle can be 0 when the angle is pi by 2 or 3 pi by 2. And now we can solve for x, like so. First, we can subtract pi by 3 from both sides. That'll make it x is equal to pi by 2 minus pi by 3. And then we can use some rules of fractions to simplify this a bit further. And what we end up getting is pi by 6. But remember, we also have to solve for the other possible value of x. So going back to the equation we had before, we'd written out before, we can again subtract pi by 3 from both sides, which gives us this. We can use rules of fractions to simplify it like so, and we end up with x is equal to 7 pi by 6. If you found this helpful, let me know. I'm more than happy to do it for several other examples. This is a bit different to the way that your teacher's done it, but I think this cuts through a bit of some algebra and it gets straight to the point of trying to find the answer to this question. But I need to warn you that this method won't always work for every single situation, which is why I think we do need to do lots of problems, and that'll make it a lot easier. So let me know if you want to continue. I'll finish off this example here, but if you do want me to finish off what your teacher's done, let me know.